Hi everyone, I am Guan Saw at Claremont Graduate University. Today I'm providing a practical introduction to the impact threshold of a confounding variable, or ITCV, in Stata. Before we start, if you wish to access to the slide that I will be presenting today, please scan the QR code on the screen. As a sensitivity analysis approach, ITCV quantified the robustness of causal inference against omitted variable bias. The core question that we are trying to answer is how strong must an unobserved variable be to nullify a statistically significant effect? Mathematically, we define the impact as the product of two correlations. The correlation between the omitted variable and the predictor of interest, which is the B path illustrated in this diagram, and the correlation between the omitted variable and outcome, which is the C path illustrated in this diagram. So the product of these two correlations is the impact that we are discussing today. To calculate ITCV with Stata, you need to install the Stata confound command by running the 4 lines of syntax here. Once the confound command is installed in your device, you can calculate the ITCV using two approaches. So now I'm going to walk you through the first approach, which you will enter the estimation result manually. So you will need 4 values from your data or estimated model. The first is the estimated coefficient for the predictor of interest. The second is the standard error. The third is the sample size of the model. And the fourth is the number of the covariates. So let's take this example from Dressman and Kimbrough from 2015, estimating the effect of eviction on economic hardship and health. In one of their propensity score models with a sample size of 122 and 41 covariates, they they found that the effect of a recent eviction on material hardship, the estimated coefficient is 1.02 with a standard error of 0.29. So this is the 4 values from the estimated models. So instead, we can use pconfound command to calculate ITCV for that particular estimated effect. Once you run the syntax that on the screen, this is the output that you would see in Stata. So there are some information about the calculated correlation and also impact. I'm going to use the path diagram to interpret the result. So to nullify the inference, an omitted variable must be correlated at 0.437 with both the predictor and the outcome in this particular study. So all the confounding impact must exceed 0.191, which is a product of these two correlations. So for publication purpose, a suggested statement for interpreting the result would be something like this. So to nullify the inference of the estimated effect of a recent eviction on material hardship, an omitted variable would have to be correlated at 0.437 with the eviction and with the material hardship. Next, I will walk you through the second approach, which is more direct. Is that if you are working on a data set in Stata, you can calculate ITCV after fitting a linear models. So I'm going to use an example from Hamilton 1983 built into the Confound package that you can download the data set and run it in your device. So in this example, we will estimate the effect of a set of predictor on household water consumption in 1981. And the predictor of interest here is the PEEP80, which is the number of individual in household in 1980s. So after running the regression, you just need to run the confound command with the variable of interest, comma, indx it. And this is the regression output. And this is the ITCV calculation output, which provide both unconditional and conditional ITCV information and also the calculated impact. And you can use the conditional ITCV to gauge the strength of the omitted variable against other observed variable, which is also provided in the outputs in these tables. So to learn more about all these ITCV, check out some of these paper published by co-authored by Ken Frank, who is the PI of this project. So you have all the hyperlink here. And also you can visit the website of KonFound-It .org by scanning the QR code here, which have Shiny Apps R packages and also other associate resources. So thank you for watching and feel free to reach out to me at guan.saw@cgu.edu. And I will see you in the next video. Thank you.